So time is very important in the disinfection process. Unlike other oxidizing disinfectants such as monochloramine, chlorine dioxide, or just regular chlorine injection, we are not governed by the same chemical reaction that occurs as those oxidizing disinfectants break down. When you put that residual into the water, it is governed by a chemical reaction. That chemical reaction, one of its governing variables is time. When you put an oxidizing disinfectant in the water, it immediately starts degrading into what we call disinfection byproducts. Those disinfection byproducts are produced as that oxidizing disinfectant goes through its chemical reaction as it degrades. You're putting an extraordinarily volatile compound into the water. That volatile compound starts to break down immediately upon entering. When you're talking about copper-silver ionization, what we're actually putting into the water is metallic ion. Therefore, it's not governed by that same chemical reaction where those oxidizing disinfectants break down. Because they're metallic, they become part of the water system. They travel throughout the water system without breaking down in the same way. Distance and time are very closely correlated. When you're thinking about water moving through your distribution system and your plumbing infrastructure, it takes time for water to cover a certain amount of distance because that water's coming in, and then it takes time for that water to make its way up through the infrastructure. So we kind of bundle time and distance together. They very much operate in the same fashion, but we like to talk a little bit about distance because it helps people understand a little bit deeper how that time variable actually plays. It's imperative for the success of a program such as Liquitex that the disinfection modality is able to penetrate and permeate throughout the entire infrastructure. Every nook and cranny needs to witness that disinfection so that that nook and cranny can get the same level of efficacy and protection. If you think back to your high school chemistry class, when you add heat to something, that reaction occurs quicker. So when you're thinking about those oxidizing disinfection modalities, when you add those chemicals into the water and you increase temperature, you're going to increase the speed of that reaction and therefore the speed at which those chemicals break down into the water. One of the most important variables when you're considering a disinfection system, the highest risk system that we work with here at Liquitech are hot water systems because they operate at the correct temperature for bacteria proliferation. So when you think about the correlation between the addition of oxidizing disinfectants and that higher temperature, you're opening yourself up to a little bit of a weak spot in your treatment modality because you're introducing something that breaks down faster at higher temperatures, and you're trying to get it into a water system that is operating at a higher temperature natively. So when you think about those two, they're very incompatible. Correct. Again, we're inserting a metallic ion into the water. These metallic ions aren't subject to those same limitations.